Hello, today I'm going to be doing a little lesson on integral test and the p-series test. Okay, so let's get right on to it. So, starting with the p-series test, I'm going to start with this because it is a much more simpler test and very easy to explain. So, whenever you encounter or like a situation that you're going to use a p-series test, it's going to look something like this first. A summation with 1 over n to the power of p. So this is like the very basic form, so you must memorize this. So, here you go, has a form of 1 over n to the power of p, and it's a very simple test. So, you see the p right over here, right? And if the p is a positive constant, you just check for these two conditions right here. If p is greater than 1, the series converges. And if p is less than 1, then the series diverges. That's basically the p-series test. There's not much more into it. So, just for like one example problem, you're given this, 1 over n to the power of 3. Then what do? You just check if 3 is greater than 1 or less than 1. And obviously 3 is greater than 1, so this series right over here is going to converge. So a basic scenario of when to use a p-series test really just defines what form you can easily identify. As soon as you see the summation of 1 over n to the power of p, or if a fraction can be simplified into this format, then I'll suggest using the p-series test because it's a very simple test because you just got to identify the p exponent and check if it is greater than 1 or if it is less than 1. It is as simple as that. So now let's get into the integral test. Oops. Here. What is the integral test? This test is slightly much more involved, but it's a very powerful test. We use it when a series is in the form of summation a to the n and has a positive, continuous, and decreasing terms. So you can compare this series to a function f of x, where the f of n is going to be the a to the n inside the summation here, and take the improper integral and then turn into this. So this right over here becomes this improper integral, and that is the integral test. So how do you know if the integral test converges or if it diverges? You just check if the improper integral converges, then the series diverges, and if the integral diverges, then the series also diverges. Always remember that you must check if f of x is positive, continuous, and decreasing on 1 to infinity. So here is a practice problem that I have made. Sorry, that's a little bit low in quality because I had to handwrite this with a mouse. You have the summation here, n to the 2 and infinity, and the function here is 1 over n to the power n 1 over n ln x. So what's the first step right here? Check if it is positive, continuous, and decreasing, and obviously this right over here, it satisfies all three categories, so we are going to use the integral test right over here. And then the first step here is to change this into an improper integral. So boom, there's the right over here. And then now you have to solve the integral. Is that correct? Yes. I think I used the u substitution right here, where u is equal to the ln x, and so the du is going to be 1 over x dx. And then you simplify the integral and you're going to get 1 over u du. Ooh, I forgot the 2 in infinity, which is going to change to ln of absolute value, ln x plus c. So now what do? You have to evaluate the improper integral from 2 to infinity, right? So what I did here is I said limit of b as is approaching infinity, and I did integral of b, this should be 2 to b, not 1 to b. But still, it's gonna be infinity over here, and you're gonna be subtracting ln of ln2, which is going to be just infinity, because this, how big this is going to be an infinity. So this integral diverges, so then the series over here would also diverge. Yep, that's it. That's the integral test and the p-series test. So a common pitfall that I want you guys to watch out for is that don't apply the p-series test unless you know it is exactly in this form right over here. You don't want to risk getting it wrong, and so if you do see this, just use it. If you don't, do not. And for integral, just always remember to check the three conditions: positive, continuous, and decreasing terms, and make sure that you understand it does not give you the sum, it just tells you the convergence. Alright, that was it for integral and the p-series test, and thank you so much and have a great day.